Hello everyone. Today we shall discuss about the various properties of integers. Today let's learn about the properties of addition and subtraction. Right? Here you see properties of addition and subtraction of integers. The first property is closure under addition. You have learned here you see we have learned that the sum of two whole numbers is again a whole number. For example, 17 plus 24 is equal to 41, which is again a whole number. We know that. This property is known as the closure property for addition of whole numbers. Right? Now, let us see whether this property is true for integers or not. Find the sum of the pairs of integers. Observe the following table now and complete it. Here you see 23, that is the number is 17 plus 23. 17 plus 23 is equal to 40. Result is an integer. Minus 10 plus 3 is equal to minus 7, and that is also an integer. Right? The next one is minus 75 plus 18. If we find what is the value, it is minus 75 and plus 18, 7. 57, this is minus 57 is equal to minus 57, that is also an integer. Result is an integer. Here this is 19 plus minus 25 is equal to minus 6, and that is the result is an integer. Plus 27 minus 27 is equal to 0, that is also an integer. Next one is minus 20 plus 0 is equal to minus 20, and that is also an integer. And the last one is minus 35 plus minus 10, that is minus 35 plus into minus is minus 10, that comes to minus 45, and that is also an integer. See, it is also an integer. Right? What do you observe? Is the sum of two integers always an integer? Do you find a pair of integers whose sum is not integer? No. Since addition of integers gives integers, we say integers are closed under addition. In general, for any two integers a and b, we have a plus b is an integer too. Right? Now we'll see the closure property under subtraction. Right? Now here you see, we will see the closure properties of under subtraction. What happens when you subtract an integer from another integer? Can you see that their difference is also an integer? Let us find out. Right? That is 7 minus 9 minus 2 is an integer. Right? And the next number is, you see, this one is minus 17 minus of minus 21, that you are getting 17 minus into minus is plus 21 and plus 1 8 to plus 1 38, and it is also an integer. Right? It is also we are getting an integer. The third one is minus 8 minus of minus 14, that is plus 14 is plus 6 is an integer. Minus 21 plus 10, minus 21 minus into minus plus 10, that we are getting 1 minus 11, and that is also an integer. Right? It is also an integer. The next one is 32 minus of minus 17, that is 32 minus into minus is plus 17, that is 17, and plus 2 9 plus 2 49 is equal to 49. It is also an integer. Right? Minus 18 minus of minus 18, minus 18 plus 18 is equal to 0. It is also an integer. And the next one is minus 29 minus of minus 29 minus 0 is equal to minus 29, and that is also an integer. In these all the cases we find that all that result is an integer. What do you observe? Is there any pair of integers whose difference is not integer? No. Can you say that integers are closed under subtraction? Yes, we can see the integers are closed under subtraction. Now you find that the integers are closed under subtraction. Now the next one is the A and B are two integers, then A minus B is also an integer. Do the whole numbers satisfy this property? Right? Now we'll find out the commutative properties. Commutative property. What is that? We know that 3 plus 5 equal to 5 plus 3 equal to 8. That is, the whole numbers can be added in any order. In other words, addition is commutative for whole numbers. Can you say the same for integers also? We have 5 plus or minus 5 is minus 1 and minus 6 plus 5 is equal to minus 1. So 5 plus in bracket minus 5 is equal to minus 6 plus 5. Are the following equal? Minus 8 plus or minus 9 and minus 8 plus or minus 9. Minus 23 and 32 and 32 plus or minus 23. Minus 45 plus 0 and 0 plus minus 5. Try this with 5 other pair of integers. Do you find any pair of integers for which the sums are different when the order is changed? Certainly not. We say that addition is commutative for integers. That is, addition is commutative for integers. In general, for any two integers A and B, we say that A plus B is equal to B plus A. We know that subtraction is not commutative for whole integers. Is it commutative for integers? Let us find out. Consider the integers 5 and minus 3. 5 minus or minus 3 the same as minus 5 minus 3 minus 5? No, because 5 minus or minus 3 is 5 plus 3 is 8 and minus 3 minus 5 is minus 8. Take a list 5 different pairs of integers and check lists. Check this. You conclude that subtraction is not commutative for integers. Yes, you conclude that subtraction is not commutative for integers. We'll find the associative property. Observe the following examples. Consider the integers minus 3, minus 2 and minus 5. Look at minus 5 plus minus 3 plus of minus 2 in bracket and minus 5 plus of minus 3 plus minus 2. The first sum minus 3 minus 2, that is, are grouped together, and in the second minus 5 and minus 3 are grouped together. We'll check whether they get different result. In both the cases we get minus 10. Here you see minus 5 plus minus 3 plus of minus 5 is minus 5 is equal to minus 5 minus of plus of minus 2 plus of minus 3. Similarly, if we take minus 3, 1 minus 7, we get the same result, right? Take 5 more such examples. We will not find any example for which the sums are different. Therefore, you can say that addition is associative for integers. In general, for any integers a, b and c, we can say that a plus in bracket b plus c is equal to a plus b plus c. Now, we will find the additive identity. When you add 0 to any whole number, we get the same whole number. 0 is an additive identity for whole numbers. Is it an identity integer again for integers also? Observe the following and fill in the blanks. Here you'll find that minus 8 plus 0 is equal to minus 8. 0 plus minus 8 is equal to minus 8. Minus 23 plus 0 is equal to minus 23. 0 plus minus 37 is equal to minus 37. And 0 plus minus 59 is equal to minus 59. 0 plus in bracket minus 43 is also equal to minus 43. Minus 61 plus 0 is equal to minus 61. And you take any number that is minus 40 plus 0 is equal to minus 40. Right? The examples show that 0 is an additive identity for integers. You can verify by adding 0 to any other 5 integers. In general, for an integer a plus 0 is equal to a is equal to 0 plus a. Right? We are getting the additive identity. Right? Now we'll find the next one. What do you see? Here you see that write down a pair of integers whose sum is minus 3. That is minus 1 plus of minus 3 minus 2 is equal to minus 3, or minus 5 plus 2 is equal to minus 3. Minus 9 minus of minus 4 is equal to minus 5, or minus 2 into minus 3 is equal to minus 5. Minus 7 minus of minus 9 is 2, and 1 minus of minus 1 is equal to 2. Minus 10 plus 10 is equal to 0. Plus 5 plus or minus 5 equal to 0. Right? Can you write more pairs in these examples? Right? We have find whose sum is minus 3. Here you see this is minus 3. This is also minus 3. Difference is minus 5, that is minus 9, minus of minus 4 is minus 5, and here it is minus 5. Difference is 2, minus 7, minus of minus 9 is 2, or 1, minus of minus 1 is 2. Minus 10 plus 10 is 0, and 5 plus minus 5 equal to 0, right? We are of integers. Can write more examples of this. In this exercise 1.2, we do it in later on, right? Let us next video we'll see the exercise 1.2, right? We will find the properties of integers in this case, right? Now we'll find the properties of integers. What is that? Multiplication of integers. We can add or subtract integers. Let us now learn how to multiply integers. Multiplication of a positive and a negative integer. We know that multiplication of a whole number is repetitive addition. For example, 5 plus 5 equal to 3 into 5 is equal to 15. Can I represent addition of integers in the same way? We have from the following number line minus 5 plus or minus 5 plus or minus 5, right? That is minus 15. But you can also write minus 5 plus or minus 5 plus or minus 3 into minus 5. 3 into minus 5, that is equal to minus 5. Similarly, minus 4 into minus 4 plus 4 in plus of minus 4 plus of minus 4 plus of minus 4 equal to 5 into minus 4, that is 20, right? And also this. Let us see how to find the product of a positive integer and a negative integer without using number line. Let us find 5 into minus 3 in a different way. First, find my 3 into 5, and then put minus sign before the product obtained. Obtain minus 15. That is, we find minus 3 into 5, we get minus 15. Similarly, 5 into minus 4 equal to minus 5 into 4, that is minus 20. Find in a similar way 4 into minus 8, that is minus in bracket 4 into 8, 30 to minus 32. Minus 37 minus 20, this is 20, this is 21. 5 into 6, that is minus 30. And 9 into minus 9 into minus 18. Using this method, we have 10 into minus 43 is equal to minus 10 into 43 is equal to minus 430. Till now we multiplied integers as positive integer and negative integer. Let us now multiply them as negative integer into positive integer. Now we find that minus 3 into 5 equal to minus 15. To find this, observe the following pattern. 3 into 5 is equal to 15. 2 into 5 is equal to 10, 5, 15 minus 5, and 1 into 5 equal to 5, 10 minus 5, 0 into 5, 0, that is 5 minus 5, and minus 1 into 5, that is equal to minus 5, right? And minus 2 into 5, minus 5 into minus 5, minus 5, that is minus 10, minus 3 into 5, that is minus 10, minus of 5, that is minus 15. We already have 3 into minus 5 equal to minus 15, so we get minus 3 into 5 equal to minus 15 equal to 3 into minus 5. Using such patterns, we also get minus 5 into 4 equal to minus 20 equal to 5 into minus 4. Using the patterns, find minus 4 into 8, minus 3 into 7, minus 6 into 5, and minus 2 into 9. Check whether minus 4 into 8 is equal to 4 into minus 8, 3 into minus 7 equal to 3 into minus 7, minus 6 into 5 equal to 6 into minus 5, and minus 2 into 9 equal to 2 into minus 9. Using this, we get minus 33 into 5 equal to 33 into minus 5, and that is 165. We thus find that the multiplying per positive integer and a negative integer, we multiply them as whole numbers and put a minus sign before the product. We thus get a negative integer, right? Now, in general, for any two positive integers a and b, we can say a into in bracket minus b minus a into b, and that is equal to minus a into b. We will find the multiplication of two negative integers. Now, can you find the product minus 3 into minus 2? Observe the following. Minus 3 into 4 equal to minus 12. Minus 3 into 3 equal to minus 9, that is minus 12 minus of minus 3. Minus 3 into 2, that is minus 6 minus 9 minus of minus 3. Minus 3 into 1, that is minus 3 equal to minus 6 minus of minus 3. Minus 3 into 0, that is minus 3 minus of minus 3. Minus 3 into minus 1 is equal to 0 minus of minus 3, that is 0 plus 3 is equal to 3. Minus 3 into minus 2 is equal to 3 minus of minus 3 equal to 3 plus 3, that is 6. Do you see any pattern? Observe how the products change. Based on this observation, complete the following, right? So, observing these products, we can say that the product of two negative integers is a positive integer. We multiply the two negative integers as whole numbers and put the positive sign before the product. Thus, we find minus 10 into minus 12 equal to minus into minus is plus, that is 120. And similarly, minus 15 into minus 6 is equal to 90. In general, for any two positive integers and b, minus a into minus b is equal to minus into minus is plus a into b. Try this, find this one, right? And now we'll find this is given a game 1. We will quit this game. After that, we'll find product of 3 or more negative integers. We observed that the product of 2 negative integers is a positive integers. What will the product of 3 negative integers? 4 negative integers. Let us observe the following. Right? Here you case consider the following statement and the resultant products. Minus 1 into minus 1 is plus 1. Minus 1 into minus 1 into minus 1 is minus 1. Minus 1 into minus 1 into minus 1 into minus 1 is plus 1. And minus 1 into minus 1 into minus 1 into minus 1 into minus 1 is equal to minus 1. This means that if the integer minus 1 is multiplied even number of times, the product is plus 1. And if the integer minus 1 is multiplied odd number of times, the product is minus 1. You can check this by pairing of pairs. Making pairs of minus 1 in the statement, this is useful in working out the products of integers. What do you find? We find that if the number of negative integers in a product is even, then the product is a positive integer. If the number of negative integers in a product is odd, then the product is a negative integer, right? Justify it by taking more examples of each kind. Think, discuss, and write. There are many things. Now we'll find the properties of multiplication of integers, right? We'll find the closure under multiplication. Observe the following table and complete it. Minus 20 into minus 5, that is 100, product is an integer. Minus 15 into 7, that is minus 255, product is an integer. Here also if we multiply all the numbers, and we'll find that all the numbers is an integer. What do you observe? What can you find out? Can you find a pair of integers whose product is not integer? No. This gives us an idea that the product of two integers is again an integer. So we can say that integers are closed under multiplication. In general, a and into b is an integer for all integers a and b. Find the product of 5 more pairs of integers and verify the above statement. Now we'll find commutativity of multiplication. We know that multiplication is commutative for whole numbers. Can you say multiplication is also commutative for integers? Observe the following table and complete it. What do you have observation? The above example suggests multiplication is commutative for integers. Write 5 more such examples and verify. In general, for any two integers and b, a into b is equal to b into a. Multiplication by 0. We know that any whole number when multiplied by 0 gives 0. Observe the following products of negative integers and 0. These are obtained from the patterns done earlier. Minus 3 into 0, that is 0. Minus 0 into minus 4 is 0. Minus 5 into 0 is also 0. 6 into minus 6 is 0 into minus 6 is also 0. This shows that the product of a negative integer and 0 is 0. In general, for an integer, a into 0 is equal to 0 into a is equal to a. We will find the multiplicative identity. We know that 1 is the multiplicative identity for whole numbers. Check that 1 is the multiplicative identity for integers as well. Observe the following products of integers with 1. Minus 3 into 1, minus 3. 1 into 5, 5. Minus 4 into 1, that is minus 4. 1 into 8 is 8. 3 into 1 is 3. 7 into 1 is 7. 1 into minus 5 is minus 5. 1 into minus 6 is minus 6. This shows that 1 is the multiplicative identity for integers also. In general, for any integer a, we have a into 1 is equal to 1 into a is equal to a. What happens when you multiply an integer with minus 1? Complete the following. 0 is the additive identity, whereas 1 is the multiplicative identity for integers. We get additive inverse of an integer when you multiply minus 1 to a. A into minus 1 is equal to minus 1 into a is equal to minus a, right? Can you say minus 1 is the multiplicative identity of integers? No, right? Can you say that minus 1 is the multiplicative identity of integers? The answer is no. Associativity of multiplication. Now we will find the associativity of our multiplication. Now we see, consider minus 3, minus 2, minus 5. Look at minus 2, minus 3 into minus 2 into 5 and minus 3 into minus 2 into 5. You can find that all are same, right? Now we find that a, for does the grouping of integers affect the product of integers? No. In general, for any three integers a, b and c, a cross b cross c is equal to in bracket is equal to a into b plus b cross c. Take any 5 values of a, b and c and verify this property. Thus, like whole numbers, the product of 3 integers does not depend upon the grouping of integers, and this is called the associative property for multiplication of integers. Now the next one is distributive property. We know that 16 into 10 plus 2 is equal to 16 into 10 plus 16 into 2. Distributivity of multiplication over addition. Let us check if this is true for integers also. Observe the following. Minus 2 into 3 plus 5, minus 2 into 8 is equal to minus 16, and minus 2 into 3 is a plus, minus 2 into 5 is minus 6 into minus 10 is equal to minus 16. So minus 2 into 3 plus 5 is equal to minus 2 into 3 plus minus 2 into 5, right? And in the same way, b is also the same. In general, can you say that distributive of multiplication over addition is true for integers also? Yes. In general, for any two integers, a, b and c, a cross b plus c is equal to a into b plus a into c. Take at least 5 different values for each of a and b, c and verify the above distributive property. Right? Now, in general, for any 3 integers, a, b and c, a into b minus c is equal to a into b minus a into c. This is for subtraction also. Take at least 5 different values for each a, b, c and verify this property also, right? That is, we can say that distributive property is multiplication, distributive property of multiplication over addition and subtraction both holds, right? And the next one is making multiplication easier. Consider the following. We can find minus 25 into 37 into 4 as minus 25 into 37 into 4, or minus 925 into 4 is minus 3700. Or can I do this in this way? That is minus 25 into 4 into 37 minus 25 into 4 into 37, that is minus 137 3700, right? Obviously the second way is easier because the multiplication of minus 25 and 4 gives minus 100, which is easier to multiply with 37. Note that the second way involves commutativity and associativity of integers. So we can say we find that the commutativity, associativity and distributivity of integers help to make our calculations simpler. Let us further see how calculations can be made easier using these properties. Let us find 16 into 12, or you can write 12 as 10 plus 2, or 16 into 10 plus 2, 16 into 10 plus 16 into 2, we are getting 192, right? Now what we get here, that these are some given examples we can find out, right? And so we can say that this is exercise 1.3 will deal in different chapters. Now we'll find out the division of integers. We know that division is the inverse operation of multiplication. Let us see an example for whole numbers. 3 into 5 is equal to 15. So 15 divided by 5 is equal to 3, and 15 divided by 3 is equal to 5. Similarly, 4 into 3 is equal to 12, gives 12 divided by 4 equal to 3, and 12 divided by 3 is equal to 4. We can say that for each multiplication statement of whole numbers, there are 2 division statements. Can you write multiplication statement and its corresponding division statement for integers? Observe the following and complete it. Right? Here you see 2 into minus 6 is equal to minus 12. 12 divided by minus 6 is equal to 2, and minus 12 divided by 2 is equal to minus 6. In this way you can find all the examples also. We observe that when we divide a negative integer by a positive integer, we divide them as whole numbers and then put a minus sign before the quotient. We thus get a negative integer, right? In this way you can say a divided by minus b is equal to minus a divided by b, where b is not equal to 0, right? And we'll find all these things. So in general, for any two positive integers and b, minus a divided by minus b is equal to a divided by b, where b is not equal to 0. Now properties of division of integers. Observe the following table and complete it. Statement minus 8 divided by minus 4 equal to 2, result is an integer. Minus 4 divided by minus 8, result minus 4 by minus 8, that is 1 by 2, result is not an integer, right? But you observe that the integers are not closed under division. Justify it by taking few more examples of your own. We know that division is not commutative for our numbers. Let us check it for integers also. Can you see that table minus 8 divided by minus 4 is not equal to minus 4 divided by minus 4, right? You can say this shows that the negative integer divided by 1 gives the same negative integer. So any integer divided by 1 gives the same integer, or in general for any integer a we can say a divided by 1 is equal to a, right? And now you see there are various examples we'll all solve later on, right? Now this is exercise 1.4. We'll do it in a separate video, right? What we have discussed now, integers are a bigger collection of numbers which is formed by whole numbers and their negatives. These are introduced in class 6. We studied in the earlier class about the representation of integers on the number line and their addition and subtraction. We now study the properties satisfied by addition and subtraction. Integers are closed for addition and subtraction both, that is a plus b and a minus b are again integers where a and b are any two integers. Addition is commutative for integers, that is a plus b is equal to b plus a for all integers a and b. Addition is associative for integers, that is a plus b plus c is equal to a plus b in bracket b plus c for all integers a plus a and b and c. Integer 0 is an identity under addition, that is a plus 0 is equal to 0 plus a is equal to a for every integer. We studied how integers could be multiplied and found that product of a positive and negative integer is a negative integer, whereas the product of two negative integers is a positive integer, that is minus 27 is minus 14 and minus 3 into minus 8 is plus 24. Product of even number of negative integers is positive, whereas product of odd in number of negative integers is negative. Integers show some properties under multiplication. Integers are closed under multiplication, that is a into b is an integer for any two integers a and b. Multiplication is commutative for integers, that is a into b is equal to b into a for any integers a and b. The integer 1 is the identity under multiplication, 1 into a is equal to a into 1 a for any integer a. Multiplication is associative for integers, that is a into b into c is equal to a cross b cross c for any integers a, b, c. Under addition and multiplication, integers show a property called distributive property, that is a into b plus c into b plus a into c for any three integers a, b and c. In the 980s, the properties of commutativity, associativity under addition and multiplication and the distributive property helps us to make our calculations easier. Also learned how to divide integers. We found that when a positive integer is divided by a negative integer, the quotient obtained is a negative integer and vice versa. Division of a negative integer by another negative integer gives a positive integer and as quotient. For an integer a, we have a divided by 0 is not defined and a divided by 1 is equal to a, right? This is our different properties of integers. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.